Now, since a statement can be either true or false, we normally like to illustrate that by making a small table, and we call this a truth table. And a truth table has on the very top the statement name or variable, in this case P, and underneath we have the truth possibilities for that statement. So in this case, the statement could be either true or false. We call this the truth table of P. Now for the negation, remember we said that the negation of P is tilde P, and also sometimes it is pronounced it is not the case that P is happening. It is the opposite of P, and it has the truth values opposite to the truth values of P. So this is the truth table for not P. Notice how when P itself is true, the opposite of P will be false, and vice versa. If the P itself is false, then the negation of P will be automatically true. So this is a truth table that you should try to memorize, the tilde P truth table. Now for conjunctions, we said a conjunction is an and statement. When is an and statement going to be true, and when is it going to be false? According to the truth table, an and statement P and Q is only true when both P and Q themselves are true. Otherwise, the statement P and Q is going to be false. And that's what we're seeing in the next 3 rows of the table. If either P or Q happens to be false, then the conjunction is automatically false. For disjunctions, remember disjunction is an or statement. Or statements are a little bit more special. For an or statement to be true, either P or Q must be true. So if either P or Q is true, the disjunction, the or statement P or Q will become true. The only time P or Q is false is when both P and Q are themselves false. So conjunctions are very restricted, whereas disjunctions are true most of the time. That's something, again, good to keep in mind. What is a statement form? A statement form is an expression made up of statement variables such as P, Q, or R, along with some logical connectives such as the wedge symbol, the V symbol, and the tilde. So it's basically a collection of symbols and statements. And we can also design truth tables for these statement forms. So for instance, not P, P and Q, P or Q are all themselves examples of statement forms. Here's a statement form, P or Q, and not P and Q. The question here is to make a truth table for this statement form. Now, there are basically going to be multiple columns in this table, and there's going to be multiple rows in this table. The number of rows, let's begin with that. Since there are 2 letters in this statement form, in this complete statement form, there are only letters P and Q. That means 2 letters. Then that means that there's going to be 2 to the power of 2 rows, meaning 4 rows in our table. So basically, how do you determine the number of rows? You raise the number 2 to the value of how many variables there are in your statement forms. So if there are 3 variables, P, Q, and R, for instance, it will be 2 to the power of 3, which would be 8. And how many columns do we need? Well, we need a column for P and Q. We need a column for P or Q. We need a column for tilde P and Q. So far that's 3 columns. And then one final column for the statement form itself. So here's an example of what that would look like. So again, the P and Q themselves are represented in this table. The P or Q is in the table because I'm seeing that first. P and Q is in the table because I'm seeing that next inside my statement form. And then finally, the tilde P and Q is in there too. So that's why you're seeing it there in the table. And finally, the statement form itself. Now let's take a look at the first row of this table. In the first row of the table, the P itself can be true and the Q itself can be true. So therefore, the disjunction is going to be true. The conjunction is going to be true. The negation of P and Q, I look at the previous column and I negate the true, it becomes false. And finally, I need to figure out what's going on with my statement form. The statement form is joining with a wedge symbol the columns P or Q with the column not P and Q. Since one of them is false, the total is going to be a false value. And we could do this again with the next row. In the next row, for instance, P could be true and Q could be false. So for the disjunction P or Q, we are going to have a true statement because true or false is going to be true at the end. Now, the conjunction is going to be false because one of my variables was false. And therefore, the negation of the AND statement will automatically be true. And now looking at the true and the true results in an AND statement that is true. We continue the next two rows in the same way, and we will end up with the following truth table for the statement form that we're responsible for. Now, typically speaking, we end up by designing the table by first figuring out what goes in the first column and second column right away. And then after we figure out what goes in the first and second column, we fill the rest of the column because it will be quicker that way. When you're designing your truth table, you want to start by first figuring out how many rows there are. In this case, we said there are 4 rows. And because there are 4 rows, we're going to split half of them into true and half of them into false. And then again, we continue. We split half of those into true and half of those into false, and so on and so forth. Okay, so try to design the following table for the statement form P and Q, or not R. So again, there are 3 variables in here, P, Q, and R. So 2 to the power of 3 is going to be 8, and that means there are 8 rows in this table. And when you design your table, you're going to make 4 true, 4 false, and then cut it by half, 2 true, 2 false, 2 true, 2 false, and so on and so forth like that. You need a column for not R, a column for P and Q, another column for the statement form completely all together. So take a minute to pause the video and see if you can design the table here. So here's my truth table. Again, I have 4 truths, then 4 false. Similarly, 2 truths, 2 false, 2 truths, 2 false, and again, I break it down in half, true, false, and so on. You gotta be careful for the conjunction to be true. You need to figure out where P and Q themselves are true. So for that portion of the table, we just look at the P and Q columns. Looking at the P and Q columns, we can see that they're both true on the first 2 rows. This is the reason why we have true and true. For the rest of the table, we have a bunch of false. The negation of R is going to look at the R column and just negate the truth values in that column. Then finally, to finish the rest of the problem, we look at the columns of P and Q, the columns of not R, and we think about what happens if we have a disjunction or an OR statement. So keep in mind that OR statements are mostly true. They're only false when we have 2 false back to back. So this is what we're seeing on the 3rd row and on the 7th row. Also here in this row, we have a bunch of false, but everything else on the table becomes true.